A common issue in many machine learning problems is the fact that for training good and accurate machine learning model, we need to have good data, garbage in, garbage out. If we are tackling a classification problem, one of the key issue is having a well-balanced data set. So a data set that contains example belonging to the different classes in equal proportion. To overcome this issue, the fact that in many real world situations we might have data sets which are not well balanced. So we might have data set where we have very few examples, very few instances of a particular class. For example, if you consider the anomaly detection problem, anomalies and failure are rare events, so they are naturally in low numbers compared to the normal situations. And to cope with this problem, so to obtain a more well-balanced dataset, which is a necessity for having good, accurate models for for classification, there exists a family of functions which refers to the name of oversampling or undersampling, which belongs to the general data augmentation family. In particular, there exist several techniques, and we have seen that, for example, with the general services provided by IoTwins, we might specify, we might have also data augmentation service for general dataset. This was the function selector number 8 here. But for the case of time series, when we have an unbalanced data set composed of time series, this is not so trivial. So there exists no ready-made software capable of augmenting time series based data set. And in IoTwins, we decided to provide this as a service. So we have the time series oversampling service, which take an input dataset composed of time series. Each time series is associated to a specific class, and potentially the training set, the dataset given as input contains unbalanced distribution of classes. We can see here how to use the time series oversampling service by creating a new deployment. So, for example, TS oversample. Here, in this case, we have only a single function because for the time series oversampling service, we only have function number 0. We require 1 CPU and half a gigabyte of RAM. We provide a file name containing the data set that need to be oversampled. So the data that it is potentially unbalanced and that we want to make it more balanced. So you see there is only a new field compared to the service before, and then you have the series of services that are required to connect to the Mini-IO browser. So we have to provide the information, the credential which pertains to your particular user for the Mini-IO storage. And then as well, you have to provide the information for the EAM client to access the PAS orchestrator. So let me provide them here. Those are the values used also for other services for my specific user. Now we can submit our service. The orchestrator will take the service into consideration and will run it. Okay, it will take some time, not too much probably, but just to give you an idea, I wanted to show you the results because I already ran the service earlier. You see here, these are 2 results. We have those are 2 different PNG images, and we have an image representing the history, sorry, not the history, but the histogram of the classes before the data augmentation, and this is the histogram of the classes after the data augmentation. So let's look at the history of the histogram, sorry, of the data before the augmentation. We open this file, and you should see here we have a data set composed of time series, and we have 4 different classes. You see that the classes are heavily unbalanced. We see that we have way more classes of memory example of class 0 and 2 respect to classes of example of classes 1 and 3. So this is the original dataset, the sample data.csv that we have fed to the service. We see instead that the balanced, that the augmented dataset, the oversampled dataset, has an entirely different look. So we have again the same classes, the same 4 classes, but in this case we see that we have augmented the minority classes by employing statistical and machine learning tools based on the generation of synthetic data, considering the local neighborhoods of the already available samples. And you see that we have the same number of examples for the majority class, around 140, but we have increased all the remaining examples for the minority class in order to reach the same number of examples as the majority ones. So now we pass from a really unbalanced dataset to a very well balanced one.